Hello students, welcome back. Let us resume our discussion in section 2. Previously we went through sine and cosine, and which was more important? Both are very important, but sine function is more important in terms of graphs, and if you understand sine, then cosine follows almost immediately. Now let's go to tangent, and the shape of tangent function, or the shape of the graph of tangent function, is fundamentally different. It looks like this: periodic, with periods just pi, not 2 pi, and we have vertical asymptotes, one after another. Why is that? Well, okay, here's the static view. Tangent is sine of a cosine, and when the cosine function is the denominator. When the cosine hits 0, we hit 0 in the denominator, and that'll create the vertical asymptote. So at pivot 2 here, vertical asymptote, starting from 0, vertical over horizontal, and angle is 0, then vertical is 0, while horizontal is same as the radius. So we begin from 0 and increase, and if this triangle here gets very close to the y-axis and become very close to the vertical line segment, we have something very close to 1 over infinitesimally small, so blow up to infinity. And once you cross and go to second quadrant, still very high in terms of magnitude, but tangent value is negative because cosine is negative from that point on. So we have the split, and we have vertical asymptote starting over. Here is the visualization, but I don't know how helpful this is gonna be. Let me run it again. Let's see. Okay. From negative pi to positive pi, in the circle here we have the definition. Vertical over horizontal. That ratio is what you're looking at. And let's stop this motion. Okay, here vertical is 0. Horizontal is the same as radius. So 0 over 1, so we begin with function value 0. Now, if I go a little bit further, angle increases, we get a little bit more negative, but also this too is negative, so negative or negative, so positive, and that's increasing, and then as you get closer and closer to this vertical axis, vertical over horizontal, where the denominator horizontal is very small, getting close to 0. So this blows up, and then we have vertical asymptote right here. And then if you pass that, now vertical over horizontal, where horizontal is positive, so this overall quantity is now negative. And then decrease. Actually, I'm setting backward. Increase towards 0. And then, yes, I'm hitting 0. And it keeps on increasing. And then toward infinity and beyond. That's the graph. Here's a graph of tangent function alongside the graph of sine and cosine. And as a matter of fact, it's a little bit difficult to see this graph of tangent function. Do you see this thin brown here and there? I can see it from my screen, but I don't know if you can see. So instead of thin brown, let's make it dashed Okay, all right. This way we have graphs of tangent function, and then one branch I have highlighted, and the others are all de-emphasized in dashed lines, dashed curves, but they are still all graphs of tangent function. And then tangent is sine over cosine. Sine is the numerator, cosine is denominator. And please note that when denominator cosine reaches 0 here, pi, we have the vertical asymptote. And then again here at pi over 2, at 3 pi over 2, another vertical asymptote. And then here, when cosine reaches 0 again, negative pi over 2, again, vertical asymptote. When sine, the numerator, reaches 0, here, well, the graph, the tangent function is just hitting 0, no big deal. Again here, and again there. As for the further properties of sine function, the further properties of tangent function, the period is pi, and it's an odd function. Yeah, you can see that. Tangent of 0 is 0. At pi over 2, undefined. At pi, again 0. And negative pi over 2, again undefined, vertical asymptote. And yeah, that's a property of tangent function. Next, other trig functions, cosecant, secant, and cotangent function. Cosecant is one of a sine, so if I picture the graph of sine function, red, and cosecant function, blue, this is what you're looking at, and as a matter of fact, it's a bit difficult to see, so let me use dashed curve. Sorry. Okay, all right. The blue curves represent the graph of the cosecant function. And then the principal branch from 0 to 2 pi, I highlighted in solid blue, and the others are dashed, but they're all part of the cosecant function. And graph of sine function is here, and as you can see, as sine function hits 0, we have vertical asymptote, blowing up to infinity, blowing up to negative infinity there. And then when sine hits the maximum, positive 1, and minimum, negative 1, 1 over 1 is cosecant, 1 over negative 1, again, cosecant. So the cosecant function and sine function touch there. So that's the graph of the cosecant function. Secant function, pretty much the same way, except that this time it's based upon the cosine function. Again, you can see all these in blue, so let's redraw it with dashed blue. Okay, all right. The principal branch from 0 to 2 pi is highlighted in solid blue. The others are dashed, but still, all these are graphs. All these are part of graph of secant function. Green is cosine function, and as you can see, the maximum 1, minimum negative 1, maximum 1, minimum negative 1, and then at those points, the secant function and cosine function touch each other. 1 over 1 is 1, 1 over negative 1 is negative 1. And then when cosine hits 0, we have vertical asymptote. When cosine hits 0, 1 over 0 is undefined, so we have vertical asymptote. Finally, cotangent function is here. Again, it's a bit hard to see, so dashed blue. And this one too, dashed rather than thin. I mean, in my screen is okay, but in case you have difficulty, Okay, first graph, I graphed cotangent function blue and tangent function brown in the same viewing window. And when tangent hits 0, 1 over 0 is undefined, so cotangent function, blue function, has vertical asymptote. And then at pi over 4, tangent is 1 right here. So 1 over 1 is 1. Yeah, at this point we have crossing. And then tangent of negative pi over 4 is negative 1. 1 over negative 1 is again negative 1, so we have crossing at pi over 4 and negative pi over 4. Here, this one is 3 pi over 4, 5 pi over 4, and so on. Alright, and then when the tangent function hits vertical asymptote, that's when cotangent function hits 0. Well, they're reciprocals of each other, so that's easy to understand. In the second picture, we have cotangent function blue, along with cosine function green and sine function red. Cotangent is cosine over sine, so we have vertical asymptote when the denominator sine function hits 0. That's when we have vertical asymptote. Here, at y-axis, that's when you have vertical asymptote, and so on and so forth. Alright, we went through the graphs of tangent, cosecant, secant, and cotangent function. But among all this, what's the most important? I'll say the graph of sine function is the most important. And then it comes from this. In the left hand side, in the unit circle, you're looking at the definition of the sine function. Vertical over radius, but radius is 1. So just vertical. And at the time, here in the graph, vertical is y-coordinate, the function value, and they match precisely. And you can see that. Let's stop and then move those around. No matter where I put, vertical here and then vertical there precisely match together. A little bit more difficult to see, but this arc length and this horizontal blue must match as well, but that's a bit hard to see. And then that's sine, and for cosine, similar. Yeah, it's like this. Similar, horizontal over radius, but radius is 1, so just horizontal only. And the function value here is represented as y-axis or y-coordinate, which is vertical. So it's a bit hard to see. This horizontal and that vertical must be the same. So you have to tilt this picture to see if they're actually matching. And that tilting 90 degrees, that as a matter of fact explains the phase difference from sine to cosine. And as a matter of fact, that explains these. Sine of pi over 2 is cosine, and cosine of theta minus pi over 2 is sine, like that. These two as a matter of fact. Alright, so much for section 2. Let's complete it here.